following video, we'll discuss Lecture 18, which is all about measurement. One thing we want to talk about when we're discussing measurement is the idea of dimension. It's important to know what dimension the things that we're measuring are in so that we make sure that we put things in proper units. It also allows us to easier calculate these things to determine whether we should be adding values or multiplying values. Sometimes thinking about what dimension we're calculating in will help us find that value out. The first thing we're going to talk about is distance. What is distance? Well, distance is the length I'm going to say of a straight line between 2 points. The important thing about distance is that it's measured in one-dimensional space. So because it's measured in 1D, we can think about examples for units as things that we normally measure with, such as feet, for example, centimeter, meter, maybe millimeter. We also measure in things like yards or miles. We use MI for miles. All of these are good examples of things that we can use to measure from the distance from one point to the next. Perimeter is something we commonly use when we're measuring in 1D, and perimeter is the distance around an object. So I'm going to write it as the distance around an enclosed object. So when we want to find the perimeter of a particular object, what we do is we just add the values all the way around. Add the side lengths. So in this first example, it says we want to find the perimeter of a rectangle that has a length of 16 and a width of 8. So maybe my rectangle looks something like this. Notice in this particular problem, we didn't have a unit attached to it, so we don't need a unit in our final answer. But if this would have said the perimeter of a rectangle that has a length 16 feet and a width of 8 feet, then we would want to make sure that we put in our answer that the perimeter is measured in feet as well. So we'll finish this up by adding the missing side lengths here. We have an 8 on this side that matches this 8. We have a 16 on top to match the 16 that we put on the bottom. And we add all of these values together. 16 plus 8 plus 16 plus 8. 48 is what I get. And so we get a perimeter of 48. Keep in mind that in 1D, we were just talking about, an object, imagine I'm a bug somewhere on this line. I only have two choices, right? In 1D, I can either go, in this particular example, either left or right. Or if I was measuring maybe this distance right here, I still, if I'm a bug crawling on this distance, I only have two options, right? I can either go up or I can go down. Then we go on and we move into 2D, and we can discuss area. So the definition for area that I'm going to use is the total space inside a closed 2D shape. So any kind of picture that I can draw on this piece of paper, flat object that I can draw on this piece of paper, so long as it's closed, I can find a way to calculate its area. And if I can find a way to calculate its area, then its measurement is going to be something that's given to us in a unit that's 2D. So this is measured in 2D. Another thing that we want to remind ourselves when we're calculating area is we are multiplying. Multiplying dimensions. So for area of a square or rectangle, we can say that the area is equal to the length times the width. For a triangle, it's actually half of that. And the way we remember that is thinking about a sandwich. So if I have a sandwich like this, I know that the area of the sandwich based on my area for square or rectangle is going to be length times width or something like that. And I can take my sandwich and I can cut it along the diagonal here. And what I did is I made two triangles. So this is why the triangle gets the 1/2 in the front. Because it's only half of this object that I'm finding the area of if I want to find the area of the triangle. We also don't use L and W, length and width, for triangle. We use B and H. They mean the same thing. The area of a triangle then is 1/2 times the base times the height. We multiply these units together, assuming that these two lengths are in the same unit. We end up getting 2D units. So some examples of 2D units could be feet times feet, which is feet to the second power, or square feet. Same thing with any of the units that we used in example 1. We just raise these now to the second power because we're multiplying a foot times a foot, or we're multiplying a centimeter here, maybe perhaps by some amount of centimeters here. And so my answer ends up becoming a centimeter squared, or a meter squared, or a mile squared, maybe a kilometer squared. So make sure that we're putting this proper unit on there. For first power, finding the perimeter, we're getting areas, or we're getting units that are in one dimension. For areas, when we find its unit, we should be expressing that in two-dimensional. So we want to find the area of a rectangle that has a length of 16 and a width of 8. Sounds familiar. The same shape that we were looking at before. I'll put 8 here and 16 here. In this case, I don't need to necessarily fill in these values because it's for the area of a rectangle. We just multiply these two values together. So my area is going to be length times width. Because we're multiplying, it doesn't actually matter which one of these you call length and which one you call width. To stay consistent, I call this length and I call this width. So I'm going to say that the area is going to be equal to 8 times 16, which is 128. Again, we want a unit on this. Right now, I'm just going to call it units squared raised to the second power, square units, because there was no units given in the problem. But I can assure you for these other ones, you will have some unit on there. We want to make sure we put that there on the end. If you want to just call this 128, that's fine for right now. I just want to give it some kind of name, so I'm going to call it 128 units, and then I put the second power up here, say that I have a square units. And again, really what that means is if I took this and I broke it up into tiny little pieces, maybe 16 little lengths going here and 8 little lengths going this way, what I would do is I'd have all these tiny little square units that are each a length or an amount of 1, area of 1. So I could technically take all these and add them all up, but really what we're doing when we do that is just multiplying these values together. In this example here, we want to find the area of the triangle. So again, don't forget the 1/2 we need in the front. It doesn't matter which one you call base and height, although the way that this is drawn, I would assume that this is our h, our height, and that this down here is our base, this flat area. I will also say for area of a triangle, this formula only is working for us when it has a right angle here. So if I had some triangle that wasn't a right triangle, I would need to come up with a different formula for area of a triangle. Don't worry about that right now. We're not going to explore any more area of a triangle formulas this semester. But there are more that exist in case we are given a triangle that doesn't look so nice like this one. So for our area of a triangle, we multiply 1/2 times 6 times 14, and that gives us 42. Don't stop at just 42. Go back, verify what unit you have here. We have feet here, we have feet here. We're finding the area and we multiply those values together, so our answer should be in square feet, or feet raised to the second power. Last one we'll talk about in measurement is going up one more dimension. We'll go up to 3D. And so 3D, we have a length, a width, and a height involved. So volume is the measurement, I'm going to say, of space in a three-dimensional object. So how much air is in the room that you're currently in, right? How much water is in that bottle? Things like that are all measures or metrics of volume. And so when we're doing volume, it's very similar to what we did with area. We should be multiplying all three dimensions. Similarly, our units example is the same. It's going to have all those units that we were just talking about, feet, for example, but now it's going to be raised to the third power, cubic feet. Also, cubic meter or cubic centimeter now. When we raise it to the third power, we call it cube because imagine just lots of little tiny cubes added up to make up a shape. There are other volume ones now that are similar. For example, a milliliter is a measurement of volume as well. It's a tiny measurement. And again, we can change, we can mess around with liter, say, milliliter or decaliter if we want to get real big in terms of our volumes. All of these are good examples. A gallon, for example, is another one that we use quite often here. So all of those are good examples, and there's a relationship between any one of these, right? We should be able to find some conversion if we were interested in finding out how many cubic feet there were in a gallon, for example. Could we do that? And the answer is yes. That is our next and last video that we'll discuss. So for these, we just have two examples. Again, area for prism or box-shaped objects is just this. We simply just multiply all three dimensions together. So if I wanted to find, we don't want to find, sorry, this is for area. Sorry. For volume is when we multiply all three dimensions. For area of a prism, we add all of the sides. And so just be careful with these. It depends on what we're asking for. I'm actually going to do two separate examples. I'm going to find the area of the outside of this box. Okay, this is also called the surface area. And then we'll also find its volume. So for its surface area, let's look at this box right here. Just like a die that we roll, this thing has a total of 6 sides. It has a top and a bottom. And the top and the bottom are shapes that look like this. On the top, we have a length of 10 here, and we have a length 5 here, and we have a height of 2 total. So the top box is going to be a 10 by 5, and the bottom is also a 10 by 5. So what I'm doing is I'm going to just deconstruct this box into 6 sides, and then we'll calculate the area of all of those, and we'll add them up. So it has 2 top and bottom, and then we have 2 I'm going to refer to as the left and right sides. This shaded area over here is like the right side, and then there's another one that we can't really see kind of hiding back here. Both of those are these skinny little sides, and they have a length of 10, and then they have this height right here, which is a measurement of 2. So we have 2 of those also. And then lastly, we have a front and back that we need to do as well. 2 and 10, and then we have 2, front and back. And the front and back have a length of 2 and a width of 5. We have 2 of those as well. So if we wanted to find the area, or what we refer to as the surface area, we're going to take all 6 of these sides and we're going to add them up. So to find the area of each of these, again, we multiply. So a 10 by 5 is going to give us 50, another 50, 10 by 2 will give us 20. This is also 20. That 2 by 5 is 10. And then we have one more 10. So if we want to find the surface area, which I'm going to use capital SA for, I need to calculate 50 plus 50 plus 20 plus 20 plus 10 plus 10. That's 100, 40, 50, 60. So 160. Make sure we have the right unit on here. The double quotation right here, that's inches. So I'm going to put inches squared as my answer. If I was asked to find the volume of this same shape, I use capital V. I go back to this here, and I'm going to multiply these three units together. The length, the width, and the height. 5 inches times 10 inches times 2 inches, which is 100 inches to the third power, or cubic inches. On your own, I ask you to try this one. This one is a little bit nicer because the surface area has 6 sides that are all the same length. So, all equal length. Well, it has, I should actually say it has 6 faces. It's more than that, many sides. 6 faces of equal area. So when we calculate the surface area, we can only need to take one of these squares, which is a 2 by 2, and multiply 6 times that value. Similarly for the volume. Our volume for this problem would just be multiplying these 3 together as well. So that's it for measurement. Surface area is probably not going to be something we talk too much about, but it's good to know. I think in your homework you have just area, perimeter, and volume.